if the computer were to pick a number at random from 1 to 100, I wonder what the, I don't know. I wonder what the expected number of guesses would be in the long run if you set the lower bound as, anyway, I don't know. Some kind of simulation there. All right. Any questions, any issues? I'm working on writing a second homework assignment that will make use of NumPy. So that's in the pipe, and we'll do that. Okay. Can't believe it's already the end of third week. Does it feel like it's going quick?
Yes.
Yes, right? That means like 2 months and you'll be graduated. Right? It's April 19th. Your graduation's June 17th. So we are less than 2 months away, which, well, you should be graduated. Some of you snuck into this class. But okay, let's see. Here I am. I'm going to finish up this NumPy business. I think we left off. Okay, so here, Boolean operators in NumPy. I think this is what we're used to seeing in R. So here I've got some range, 0 through 5, and then you can put in some kind of comparison thing, and then it will turn everything into trues and falses. Okay, and these behave exactly as you would expect. Okay, so are they less than 3 or greater than or equal to 3? And we get, trues and falses exactly as we would expect. And then, and you can use that true-false array to subset another array or the original array or whatever you want, right? So here, if I say print x, where it's, subset by x greater than or equal to 3, then we get exactly what we expect, 3, 4, and 5, okay? And also, you can take, if I do this, sum x greater than or equal to 3, this will upcast the true-false vector into 0 and 1s, and it will give you back the sum, and you can throw it into mean, and it will give you back the mean, okay? So I think this behavior is easy for you guys to understand because it's exactly what how R behaves as well, right? Okay, now let me talk about matrices. So matrices are two-dimensional ND arrays, and we know that they're two-dimensional because we see the double square bracket here to indicate, we've got each of these rows. And so, we did 0 through 11, and we reshaped it to be 3 rows and 4 columns, okay? If I throw the matrix into a, whatever you call this thing, comparison operator, then it will turn into a logical, or not a logical, a Boolean matrix, okay? Everything, just as element-wise comparison, we get trues and falses. And then again, you can throw this into NP sum, okay? NP sum does what? It will, so what will I get back if I do this command here? 6, okay? Just a single number, 6. It's going to say how many true values are there in this matrix. It turns everything into 0s and 1s, false 0, true into 1. We get 6, okay? Here, I've got NumPy sum y greater than 6, so I'm summing up this thing, and I say axis equal to 0. So what's that going to do? 1, 1, 2, 2? Yeah? Okay, because it summed via the columns, right? So it looks at this first column and it goes false, false, true. So that's 0, 0, 1. What's the sum there? 1. What's the sum here? 1. What's the sum of this third column? 2. And the sum of the fourth column is 2. So we get 1, 1, 2, 2. And then if I do NP sum axis equal to 1, we're going to get what? 0, 2, 4. Exactly. Okay. And these are one-dimensional arrays. So the shape of this is 3 comma. The shape of this is 4 comma. Okay. I think we're also familiar with these kinds of things. So here I've got these true-false vectors, these Boolean vectors. And then if you want, it's just the symbols maybe a little bit different. So if you want and, so it goes element-wise, you use the single ampersand. And so that's going to give us true only where both are true. And we get false if one or both are false. And then the or gives us, returns true if either one are true. And we get false if both of them are false. This operator, okay, we're accustomed to seeing this as like a power, but in Python, power is the double asterisk, and here the caret is exclusive or. So exclusive or means one is true and one is false. Okay, so it returns true if one is true and one is false, and it will return false for both being true or both being false. Okay, so if both are true, we get a false, and both are false, we get a false. And if the other way. Okay, and then the not. This is also a symbol that takes a little bit getting used to because we're kind of accustomed to the exclamation point. You use the tilde. You use the tilde to negate a Boolean array. Okay, so A is true, true, false, false, and then when you negate that, you get false, false, true, true. All right, and then any and all these exist in R as well. If any of them are true, it's going to return true. If all of them are true, and then all will return true only if all of them are true. And so we get false back there. Okay, so these are kind of your Boolean operators. It's just, I think these two symbols just, I still get them mixed up all the time because switching from Python and R, like sometimes I type len versus length and things like that, right? R, you have to type out length. In Python, it's len, and then, you know, you get this and you get that, and they all get mixed up. It's normal, I think. So earlier we talked about how regular lists don't support fancy indexing, meaning like you can't just, so in a list, you can't say I want like the first element, the third element, and the fifth element or something like that. But NumPy allows you to do that, okay? So here is 10 random integers from 1 to 99, okay? And we'll get this, and here I say I want the 0, index 1, first index 0, index 1, and index 5. And NumPy says, okay, here's index 0, index 1, and index 5. Okay. You can also, so here I've got a matrix of kind of indices that I want to select. Okay, so I want index 1, 4, and 7, and 2, 3, and 8. And then if I subset X using this, what will I get back? I will get basically a 2 by 3 matrix where you know, it's going to go 12 and then 75 and then 64 and so on and so forth. So it finds index 1, index 4, which is 75, index 64, index 7, which is 64, and it fills out the matrix this way, right? So we've subset X, this thing using these indices, and it fills it out. Okay. Here's another matrix X with numbers 0 through 11, reshaped to a 3x4 matrix. And here I've got row 0, 1, 2 and column 2, 1, 3. And I say subset X with row and column. So it's going to pull back, what am I going to get back? An array of length 3 with the intersection of row 0, index 2, and then row 1, I guess row index 1, column index 1. So I'm going to get 2, 5, and then row index 2 and column index 3, 11, I think. Okay, so 2. So 2 is row index 0. So we're basically giving it kind of like a list of coordinates. We give the x coordinates I want, or the row coordinate and the column coordinate, right? So I say I want row index 0, column index 2, which is 2, row index 1, column index 1, which is 5, and row index 2, column index 3, which is 11. Okay, we've got sort and argsort, and I think these do what we expect them to do. So here I've got, I just shuffled the numbers 1 through 4, or 0 through 4, and so X sorts in place. So the sort happens here, and it modifies X directly. Okay, it modifies X directly, and so when I print out X, it's going to be the sorted version, or not the sorted version. It's going to be X after the sort operator has been applied to it. Okay, so again, you have to kind of remember that these things are mutable. So this array, the array happens here, the sorting happens here, and if I didn't print out X, it doesn't like print anything onto the screen that says now I've sorted X. Okay, we just have to know that because I've called sort on X, x.sort, X is now sorted, and so now when I call the print function on it, it prints out the sorted X. Okay, here is Y, which is 5214, and argsort. This will tell you the indices that you need in order to sort them from least to greatest. Okay, so what will argsort return? So Y will return 5214, and what will argsort return? 2130, exactly. Okay, because it goes 5214. So if I wanted to sort them from least to greatest, I would first have to select 1, which is at index position 2. Then I would select 2, which is at index position 1. Then I would select 4, which is at index position 3. And then I would select 5, which is at index position 0. Okay, so that's what argsort does. And then, so if I say D is argsort, and then I subset Y based on argsort, then it gets sorted in order. It returns the sorted array. Okay, is that good? And then we can kind of further this in kind of matrix forms and stuff. All right, so here I've got just a bunch of integers, 0 through 9. Okay, so I did random int, so between 0 and 10, but 10 is exclusive, so I get 0 through 9, and then just arrange them into a 4x6. So I've got 24 numbers kind of turned here, and so here if I do sort, so here I'm calling np sort not, so there's a difference. If I call x.sort, it sorts x in place, but here I'm calling the sort function, and it's going to sort along axis 0. Okay, so what we end up getting is it takes this column 5, 1, 5, 7, and it sorts them 1, 5, 5, 7, and then it takes this next column 8, 7, 2, 9, and it sorts it 2, 7, 8, 9, and then this next column 9, 6, 4, 1 gets sorted into 1, 4, 6, 9, so on and so forth. If I do, I can do the same thing, but with axis equal to 1, and it sorts them left to right, each row. Okay, so that is, so I'm going to go ahead and do a restart run all. Oh, I forgot I have the time it thing, which takes a little bit to run, but we'll go ahead and let it do its thing, and I'll save that and upload that. Okay. We covered a lot with NumPy, and I think for most of you, a lot of the things in NumPy will be okay. Won't give you too much trouble because you're used to kind of working with vectorized operators in R. But there's a few things like the broadcasting, which is going to be some behaviors that are unexpected, and then also the fact that they're mutable also might cause things to behave in ways that are slightly unexpected as well. Oh, I got an error, so it bombed out. Okay, let me just finish running all of this stuff really quick. I think I purposely put in that error. Okay. So we'll go ahead and save this. Oh, it's already saved. And close and hold. And then I'll go ahead and just check the status. So we'll add that. Git commit final 0302 final and git push. Okay, so now the final version's up there, and you can fetch and merge into your thing. All right, so now we have list comprehensions. List comprehensions, I think, are like, I don't know, one of the coolest things that Python does, okay? In that a lot of times you want to like run through a collection, like a vector, you know, or an array or a list or a dictionary or something, and then you want to take all of those and you do some kind of operation and it spits back a result, and you want to keep all of those results in a new list. Okay, that's like, I think, a fairly common thing that you want to do, right? And in R, the way we would do this is we would kind of create like an empty list to store all of the stuff, or an empty vector, and then we would write a loop, and then we would have to say like, take the you know, assign whatever the object is into this positioned index in the thing in R. But with Python, yeah, and in Python you can do something similar, and you can do something like, for, you know, each value in the collection, if something is true or whatever, you can just start off with an empty list, and then and you can just use the append method, okay? And so this would work, but I think it's even easier with a list comprehension. So all you do is you just kind of, it's almost like writing the for loop within list brackets, okay? So it's like you're writing a for loop inside the list bracket, and it basically will run through whatever it is and store the result as a list, okay? So, you know, here's just kind of a very, very simple list comprehension. So I say for x in range 1, 11, right? So range 1, 11 is what? 1 through 10, okay? And so I say for x in 1 through 10, basically, we want to store x star star 2. So we're going to take x squared, okay? So basically, this is going to make, take x squareds for, for all the values in 1 through 10, okay? And so when I do that, I get back a list that says, 149 through 100, okay? If you wanted, so this is a regular old list in Python, okay? And we can tell it's a list and not an array. Why? Because there's commas, okay? So lists will have commas, and these NumPy arrays don't have commas, okay? So here, well, unless, if you do print, I should say. Okay, here it says array, and then there's commas, but if I printed it, there would be no commas, okay? So here is, this is what we have, okay? Same thing, now it's an array, all right? You can also do the same thing, x squared for x in range 111, and then you can throw in a condition, like if x is odd, right? So x mod 2 equal to 1, that's going to be true only for odd numbers, okay? And so so this will give us just the squares of the odd numbers, right? 1, 3 squared, 5 squared, 7 squared, and 9 squared, okay? So this is pretty great. You can do stuff with strings. So I wrote the comments here, but what's it going to do, right? So it's going to do go through each word in this list of strings, and it's going to make them uppercase, but only if the length of the string, meaning how many characters it has, the length of the string is greater than 2. So it's going to take all of these things, and it's going to return back what? That card dove Python, but shouting, okay? And that's what we have, okay? So so it's like writing a loop, but within kind of within the list brackets itself, and again, I think once you get accustomed to writing a few list comprehensions, it's actually a lot easier to read code where they've used list comprehensions, because here it's very clear. It's kind of just like telling you what's going to be in the list, right? It's going to say, all right, we're going to take this thing and we're going to just put them into this list based on these things. Whereas over here, you kind of have to parse through the code and say, all right, which you have to kind of think sequentially through the loop, okay? And I think with the list comprehension, you can kind of just think of it as another list, but with a few conditions and stuff. Okay, so here, what is this going to do? I guess I've written the comments that tells you what it's going to do. But here my string is hello blank or hello space 963.257 space world, and what we're going to do is we're going to store int x for x in string if x is digit. Okay, so again, a string we can treat as an iterable, and it's going to go character through the string, and we're going to say is this character a digit character? Okay, so that's only going to be true for 963.257. And if I just did store x for this, we're going to get the digit character 9, the digit character 6, the digit character 3. Okay, but what we want is we want to convert them into actual numbers, and so we use this int operator to turn everything into a number, and so we get the integers 963.257. Okay, so this is quite powerful, right? You can do stuff. You can work over a dictionary. Okay, so if we look at what d.items is, it's a list of tuples. Okay, so we can So what is this going to do? What are we going to get back? So it's going to, the thing that it's going to store is going to be key plus is for value, okay? And it's going to go through this list of tuples, and it's so for each tuple, it unpacks them, and A will go into key, and apple will go into value, okay? And so it's going to store basically A is for apple, all right? And it's going to do that for each of these things. So we get A is for apple, B is for banana, C is for cookie, except we have this thing where it says if key is not equal to B. So what will we get back? We'll get back a list of two strings. One is going to say A is for apple, and the other is going to say C is for cookie. And so that's pretty cool, right? I don't know. I'm excited. All right, this is, I think you guys are not excited, but list comprehensions, they are. You're gonna, like, when you go back to R, you're gonna be like, oh, I wish I could have list comprehensions in R. I don't know, maybe. Use them enough, you'll love them. Okay, and then so we have list comprehensions, and then you also have dictionary comprehensions, right? And so you do whatever you want, right? So you can also create a dictionary, and except dictionary entries need to have two things. So you'll have an expression for the key, an expression for the value, and then and it's written the same way for value in collection if condition, right? So here I've got fruits is apple, mango, banana, and cherry. And what is it going to do? It's going to do F capitalized colon length F for F in fruits. So what will I get back? I'm going to get a dictionary, and the first thing in there will be capitalized apple, and it's going to have colon. So the key is capitalized apple, and then the value is 5. How many letters are in the word apple? Okay, and the next thing is going to be capitalized mango, and it's going to have 5 for how many letters are in mango. Okay, so we got apple 5, mango 5, banana 6, and cherry 6. So it goes through, tells us how many things. Okay. So here is, did I delete this? Create a dictionary where the key is the index and the value is the string in the strings list. The key is the index. I don't know. I'm not sure. Okay. I don't know what I wrote to myself there. Okay, we have, I'm sorry. This is what we want to do, and then the way we're going to do this is, so here we have a list, and then if we run this thing called enumerate goes through and it creates tuples out of items in a list. Okay, so enumerate goes and creates tuples, and so it's going to say A. We're going to have the first tuple is 0A, the next one is 1 as, 2 bat, so on and so forth. And then we can create the dictionary where we've got the index and the value, okay? And so it's going to kind of unpack this list of tuples that are in enumerate strings, okay? And it unpacks that and it creates the dictionary that we want, okay? So we have index 0 going to A and so on and so forth. And so this is a kind of a mapping that we want created here. Okay. I wrote, note that enumerate returns tuples in the order in the creation of a dictionary, and you can swap those positions and even apply functions to them. Okay, so when you do enumerate, it goes, it creates 0 and a, and I unpack those as index and value. Okay, and I created the dictionary as index colon value. But I could also just as easily create a dictionary where it's value colon index. Okay, and so this will kind of just swap which one serves as the index and which one serves as the value. Okay, and so a dictionary is very useful for looking up something. So if you want to look up 0 and a, or if you want to look up 1, you use the dictionary, right? Dictionaries are unordered, but they have fast lookups. You know, they're optimized for you give the dictionary and basically, you know, you can think of it like, what's the definition of this word? And the dictionary, you know, you give it the word and it will find it, and it will give you back whatever value, or in this case, the definition that's associated with it. So if you wanted to look up the index, you would look at it this way, and if you wanted to look up kind of the word instead, you can do it this way. Okay, so index map. If I do index map subset A, what will happen here? I'm going to get an error. I'm going to get a key error because I'm saying look up the letter A, but the letter A doesn't exist as one of the dictionary keys. Okay, so this will return a key error. Okay, because A is not a dictionary key. I have to look up values like 0, 1, 2, 3, or 4. Okay, the location mapping though, that works. That works just fine. Okay, because A is one of the keys. So dictionary is only able to look up things in one direction. Okay, you look up the key and it can return the value, but it has a hard time doing it the other way. You can combine dictionaries with kind of something called quargs. Okay, and so here you do something called quargs stands for key word arguments. Okay, and you use kind of this double star notation for. So this is a dictionary, and so I do, you know, double star notation and double star notation here, and it kind of unpacks all of those keyword arguments, and in this case I'm creating a dictionary called D, where I just basically unpack this dictionary and unpack this dictionary and create a new dictionary out of those things. Okay, so this is one way to kind of combine two dictionaries. And so I've got, you know, A where the words are the index, and I also have where the numbers, the words are the keys and the numbers are the keys. Okay. However, this is not the recommended way for combining a dictionary. Like if you had a dictionary and wanted to extend it with more dictionaries, generally the recommended way is called update. And so here I take location mapping, which is currently this, and I just do dot update, and I give it the other dictionary, and then it combines everything together. Okay. And for whatever reason, it prints it out vertically here, but there you have it. Okay. So that is that's dictionaries and kind of extending dictionaries. So lists have nice little things, like you can do one list plus another list and it just sticks them together. Dictionaries don't have that ability. You have to use the function update, and that's to prevent, because if you just did a plus and there's a conflict between your first dictionary and your second dictionary, meaning like this dictionary has a key A and it equals 10, and the second dictionary has a key A and equals 100, if you just did kind of the plus, it's not sure which one overwrites the other, okay? And so when you do update, you're taking this one and everything in here, if there's a conflict, this one will overwrite the ones down here because you're updating using these values here, okay? So you're taking this and you're gonna update it using the new values. So if there's a conflict, it gets resolved with update, whereas the plus is a little bit ambiguous. All right, so here you can use something called input. And in Jupyter, when you call input, it creates a blank space here. And we can see that this cell is still running because it's waiting for me to type something. So here I'm going to say Miles, and then and so here name is what I typed in, and then it returns back hello Miles. Okay, and that's what we have. Whatever you put in here, okay. You can put in numbers and stuff, but it's always going to come back as a string, okay? Okay, so here is a guess the number game, but I'm guessing, okay? The human is guessing, right? So this is, you're going to make something better where the computer's guessing, okay? But here I just say, you know, it starts off and it asks for input and it says, you know, what's your name? And then it's going to come back and it's going to say, hello, my name is, hello, blah, blah. And then I'm thinking of the number here, and you have up to 6 guesses, which is like amateur hour for 1 through 20. But it's going to do this, right? So, okay, so I will type in my name. All right, I'm thinking of a number between 1 through 20. We're going to do this. All right, you have 10. Your guess is too low. Take a guess. All right, so I'm going to go with 15. Okay, now I will go with 18. What is this? All right, 19. 20, okay. Well, yeah. You got me, computer. But I still got you in 5 guesses, which is what's required, right? Because 2 to the 4 is 16, 2 to the 5 is 32. So if I've got 1 through 20, I should be able to do it in 5 guesses no matter what. Okay. Yeah. All right. So anyway, so that's that. All right, functions and scope. Okay. So you guys remember scope, right? This is like our favorite thing. And so just like a bunch of other stuff, when a function runs, it's you know, the variables inside functions only exist inside the function, but if inside the function you're calling for something and it doesn't exist inside the function, it will search a higher scope. Okay, so R took, you know, kind of similar scoping rules, and so here I've got x, y, and z equal to 1, 1, and 1. Okay, so these are all equal to 1. And so this is really nice, right? So in R, this would normally take 3 separate lines, or at least separated with semicolons, but here you can just do tuple assignment and unpacking. And so here I'm going to create a function called f, and I say y is equal to 2 here. I assign the value 2 to y, and I say return x, y, and z. And so when I call f, it's going to return what? 1, 2, 1, okay, as a tuple. And then, but if I call x, y, and z, these x, y, and z will remain 1, 1, and 1 in the global environment, right? So I get this tuple 1, 2, 1, but then x, y, z still remains 1, 1, 1 in the global environment. Okay. Here I have g defined inside of f. You remember these examples that we did? Okay. All right, so what's going to happen here? So I call f. So we're going to get 1, 2, 3, and 1, 1, 1, right? Okay. Over here, I define G in the global, and I define F in the global. So if I call F, what will this do? So here's the question. Is it going to give you 1, 2, 1, or is it going to give us 1, 1, 3? I'm going to... Right? So what happens here is we assign 2 to y, but this exists only inside f, and then we call G, all right? And so G runs, and G says 3 goes to Z, and it's going to return. It's going to look for X, and it says 1, and G is going to look for Y. Y is defined inside the global environment, so when it can't find it inside G, I'm sorry, Y is not defined inside G, but G is defined inside the global environment, so when G can't find Y, Python looks for it in the global environment. So it's going to give us back 1, 1, 3 here. And that's what it passes back to f, and f had no use for this value 2 here, okay? And everything in the global environment remains 1, 1, 1. Okay, we have keywords like global, and there's also non-local, okay? So here I've got 1, 1, 1 in the global environment. I assign 2 to y, and I define G inside of f, and inside G I use the keyword global. I say global Z, all right? And so now suddenly Z has direct access, G has direct access to the Z variable in the global environment. So they don't use super assignment, but you use these keywords and you say, don't create this variable inside the function as we normally do, which is kind of our normal rules, but we say, I want you to directly access Z in the global environment. Okay, so now when I assign 3 to Z here, it changes it in the global environment. So I'm going to get back 1, 1, 3 and 1, 1, 3. Oh, I'm sorry, 1, 2, 3, because I forgot, I assigned the 2 to y here, okay? So when I return x, y, and z, it looks for x, it doesn't find it, and it finds it in the global one, and it looks for y, and because g is defined inside of f, it takes the 2 that's inside of f, and then the z is the global z, which has been modified. So we get 1, 2, 3, and 1, 1, 3. Now, how much time did I spend on this scoping stuff? Okay, we're gonna run out of time. Again, story of my life here. Okay, so G, has a local Z, but F uses a global Y, and so here, when I say print G, okay, it's gonna, this should say F. Okay, print F. It's gonna first, it's gonna run all of this stuff, and it runs. Oh wait, no, I guess I had it the way I wanted it. Okay, so G, it's gonna run G, and it's gonna just do this, and it's gonna return 1, 1, 3 and 1, 1, 1. When I do F, I'm gonna modify the Y in the global to 2, and now I'll get 1, 2, 3 and 1, 2, 1, and then and if I run G again, now I will get 1, 2, 3, 1, 2, 1. Yeah. Okay. We'll end there. Have a good weekend, good Easter, and we'll see you guys on Monday.